Hi guys, so we're the project group reviewers and today we're making our final presentation. So the large motivation behind our project is that we want to consider the scenario where if I were a restaurant owner, I want to know what kind of restaurants should I open. How do I gain better ratings, make more profits, or even just to stay in business? What attributes do my users care about? We want to look at things such as different restaurant types, topics people mention in their reviews, etc. to help restaurant owners make better organizational and marketing decisions. We collected our data from Yelp, US Census Bureau, and USD Economic Research Service. These are all official data sources. We chose them because they're huge and relatively clean and ensure the credibility of our data. We did some further data processing on the datasets. For the Yelp dataset, we filtered out the businesses that we're not interested in and removed the corresponding reviews. We also used an API to get the FIPS code of the county that each business is located in. This left us with a good amount of data points. For the demographic dataset, we computed values such as population growth, race, gender distribution, etc. The number of data points that we have corresponds with the number of counties in the US. And for analysis, we focus on two main directions. The first one is what aspects of a restaurant do customers care about the most? The second one is how does competition impact a restaurant's performance? And now we will go into the details of each direction.
To understand what aspects of a restaurant users care the most about, we first need to find which topics are mentioned most frequently in the reviews. To accomplish this, we need to calculate the percentage of reviews that cover each one of 5 predefined topics: food, beverage, price, service, and waiting time. We manually labeled a subset of the review sentences, assigning one topic to each sentence. Pre-processed all sentences by calculating their TF-IDF representation to find out the relative importance of each word in a sentence in a collection of reviews. Then we use singular value decomposition to reduce the number of features or dimensions that represent each sentence. The pre-processed label sentences serve to train and test multiple models on binary text classification, whether or not a sentence is about a particular topic. Finally, we choose the model with the highest performance metrics. When looking at the performance metrics, we notice that the accuracy score of the baseline or dummy model is extremely high due to class imbalance in our data. Many more review sentences talk about one topic, say food, than the other, say price or service. The solution is to include the Cohen-Kappa performance score to evaluate our models because it performs best in class imbalance scenarios. These performance metrics subtract from the score of a model the probability that the predicted label and the true label agree due to random chance, which is highest with class imbalance. Cohen's Kappa score can be a value between -1 and 1. By looking at both metrics, we identify that the best model to determine whether or not a sentence is about beverage is multilayer perceptron. For waiting time and price, the best model is also multilayer perceptron. Similarly, the best model for service labeling is a decision tree. However, looking at the low Cohen-Kappa scores, none is a good model to determine whether a review sentence talks about food or not. Thus, for the food label, we use a pre-trained transformer model that is pre-trained on significantly larger amounts of data. This model is a sequence-to-sequence transformer. We input the sentence and the output is a vector of probabilities. Each value of the output vector is the probability that the sentence talks about a particular topic. Possible topics of a sentence are given to the model at the time of running the classification. The sentence is about the topic with the highest probability in the output vector, and the set of topics of all sentences in a review are the labels of the review. Finally, we test the accuracy of the highest probability labels against manually labeled reviews. By looking at the confusion matrix, we can see that the model has high accuracy. Additionally, it has high recall, which means that the model labeled most of the positive observations correctly, and high precision, which relates to a low false positive rate. We use the best model we have for each topic to predict whether or not each review talked about it. Around 90% of all reviews talked about food, which leads us to conclude that food is the most important restaurant feature to customers based on mentioned frequency, followed by the quality of the service offered and the price of the menu items.
Part of our investigation, we want to understand the impact of customers' demographic identity on their food preferences. We wanted to see if Asian restaurants have higher ratings in counties with above average Asian population, and we also want to see if that's the same trend for Hispanic restaurants. To do this, we used two sample-related t-tests. We found that in counties with above average Asian population, Asian restaurants receive higher ratings on average. However, we did the same analysis over all counties and found that Asian restaurants still receive higher average ratings. The same trend persists for Hispanic restaurants. In counties with above average Hispanic population, Hispanic restaurants also receive higher ratings, but that's not unique to those counties either. Rather, it is true for all counties. Therefore, we conclude that people's demographic identity might not influence their preference, but perhaps cultural restaurants are, in general, favored. Following what we have discovered in the exploratory phase, we now want to see whether cultural restaurants receive better ratings than the non-cultural ones. We defined 5 different cultural groups: Asian, Hispanic, Western, African, and cultural in general, based on category labels of the restaurants. We have also fine-tuned our test by removing the businesses with category labels that are not relevant to restaurants. And then we formed our hypothesis. The null hypothesis states that, across all counties in the dataset, there's no difference between the average rating received by cultural restaurants and that received by the non-cultural ones. The alternative hypothesis states that cultural restaurants tend to receive higher average ratings. And to test our hypothesis, we run 2 sample-related t-tests for each of the 5 cultural groups. And here's the table showing the test results. We can see that for each cultural group, the t-test in both train and test dataset leads to statistically significant results with low p-values. Thus, based on the test statistics and the p-values, we conclude that cultural restaurants do receive higher ratings than non-cultural restaurants on average. And here are the graphs showing the average rating across all counties of different cultural restaurant groups versus the non-cultural restaurants from the train and the test dataset. And we can see that in both graphs, the non-cultural restaurants have the lowest average ratings.
The second direction of our analysis is how does competition impact a restaurant's performance? We added a new attribute called business density to each restaurant. This is the number of restaurants within a range of 2 kilometers from that restaurant. We explored 2 aspects of a restaurant's performance. First, we wanted to see if competition impacts a restaurant's ability to stay in business. In our exploratory phase, we found that there is a negative correlation between the level of competition faced by a restaurant and whether it stays in business. Therefore, we formed our first hypothesis. Restaurants that go out of business tend to face more competition. We used a one-sided 2-sample t-test to see whether there is a significant difference in the level of competition between open and closed restaurants. We got really low p-values on both our training and testing datasets. Therefore, we can reject our null hypothesis in favor of our alternative hypothesis. One interesting fact is that the p-value is much higher for the testing set. We compared the graphs and found that this disparity is likely due to the fact that the testing set is much smaller than the training set. Hence, the range of data is also more limited, making the difference between open and closed restaurants less significant. The second aspect we explored is how competition affects the amount of customers. From our daily experiences, we recall that similar businesses are typically located next to each other. So we hypothesized that some amount of competition may actually be helpful in drawing more customers. We divided businesses into 3 categories: those located in areas of low, medium, and high business density. Because popular restaurants typically receive more review counts, we made the assumption that review count is an approximate reflection of the number of visitors. We understand that population size might also be a confounding variable, in that bigger populations might result in higher review counts. So we further split the restaurants into 3 population groups and wanted to explore the trend within counties of similar population sizes. We use the value relative review count for comparison because it represents the number of customers proportional to the population size of the county where the restaurant is located.
Alright, so now we plotted out the graphs to see the influence of competition on relative review count. We see that for counties with small population, the analysis is not really applicable because all businesses in those areas face little to no competition. For counties with a medium population, restaurants facing moderate competition have more visitors than those facing lower to much competition, and this aligns with our intuition. For counties with high population, businesses facing moderate competition do have more visitors than those facing little to no competition. However, there is no restaurant facing high competition at all. We feel that one potential reason for this is that although the population in those areas are large, the population density may be low. From these findings, we formed our hypothesis. Firstly, we compare businesses facing low and moderate competition. In this part, we restrict our analysis to counties of medium and large population size. We hypothesize that businesses facing moderate competition have more relative visitors than businesses facing low competition and use a one-sided two-sample t-test to verify this. We see that in both our training and testing data set, and for both counties with medium and large population size, the p-value is low enough for us to reject the null hypothesis. Therefore, we conclude that moderate competition is indeed helpful for gaining more visitors than having little to no competition. For the second part, we compare businesses facing moderate and high competition. Here, we restrict our analysis only to counties of medium population size. We hypothesize that businesses facing moderate competition have more relative visitors than those facing too much competition and use the one-sided two-sample t-test again. Here, we see that although the p-values are quite low, especially in a training data set, it's not low enough for us to prove a statistical difference, so we cannot really conclude that too much competition is harmful, although that's our natural intuition. In all cases, our training and testing data set lead us to draw the same statistical conclusions. We can also see from the graphs that although the magnitude of the differences are different, the trends in both data sets are the same, which is that moderate competition helps to draw more customers than low competition, but it's not necessarily better than high competition. And this marks the end of our presentation. Thank you for watching.